Good morning everyone. Welcome to the workshop. Today's topic is test of significance. At the end of this topic, you will be able to understand the different kinds of tests possible and then how to carry out the testing of hypothesis in SPSS. All scientists work for looking to the answer for the following questions. How probable the difference between the observed and expected results? That means the experiment they have carried out and then original results. And is there any statistically significant difference? So many of them have a possible kind of a question, what is the significance means? Though testing of hypothesis, a very integral part of data analysis, will explain these questions. So here we learn about some basic terminologies, population and sample. Population is any finite collection of elements, that is individual items or observations, etc. Apart a subset of population, but the basic problem of this sample is generalization. Parameter and statistics. A parameter is a constant describing a population. A statistics is a quantity describing a sample, that is a function of observation. And a standard error. The standard deviation of a sampling distribution is called a standard error. It provides the estimate that how far from the true value of the estimated value is likely to show. So it is given as sigma divided by root n, that is standard deviation divided by root n. So confidence intervals. Confidence limit is the range within which all possible samples mean will lie. So a population mean plus minus 1 standard deviation, error limit correspond to 68% of sample mean value. A population mean plus or minus 1.96 standard error corresponds to 95% of the sample mean values. And population mean of plus or minus 2.58 standard error corresponds to 99% sample mean values. So here we focus on 99% is 1% level of significance, 95% is 5% level of significance, and 68% is 10% level of significance. So here interval is a confidence interval. That means it lies within this range. Everyone has so many questions about p-value. P-value provides a significant departure or some degree of evidence against null hypothesis. P-value derived from statistical tests depends on the size and the distribution of the effect. P-value less than 0.05 is equal to significant 1.96 standard error of 95% confidence interval. P-value less than 0.01 highly significant 99% confidence interval. The non-significant departure does not provide the positive evidence in favor of hypothesis. It always depends upon the sample size too. And when we focus on the errors, we have two kinds of errors which are occurring. So type 1 error, rejecting H0 when it is true is called as type 1 error. And type 2 error is accepting H0 when it is false is called as type 2 error. Hypothesis. A statistical hypothesis is a statement about the parameter, forms of population. It's a kind of a claim or a statement or an assertion which you generally make seems to be true, but a data is required to prove your claim under statistical evidence. So it is a null hypothesis and an alternate hypothesis form. So whatever the claim which you do is in the form of null hypothesis, and against it is an alternative hypothesis. So null hypothesis is always denoted by H0, and it is a hypothesis of no difference between the outcome variables. And alternative hypothesis is defined as H1, that there is some difference between the two variables under study. The hypotheses are always about the parameters of the population, never about the statistics from samples. So here test of significance, we should need to focus. Testing is always focus on testing the null hypothesis only. we frame certain hypothesis, consider that as a null hypothesis, and we keep on testing whether it is true or not. So generalized procedure in testing a hypothesis. First we need to frame our hypothesis, define the alternative hypothesis, and we need to identify the suitable test, either t-test, chi-square test, z-test or f-test or whatever the test which comes under consideration. And then we need to calculate the test statistics, and we need to see the table value accordingly, and then we determine the degrees of freedom and see the probability value, p-value. Accept or reject the null hypothesis depending upon the p-value, whether it is significant or not. So if it is less than 0.05 for 5%, if it is less than 0.01 for the 1%, depending upon that we accept or reject the null hypothesis. After this, we draw the inference. So we have a very important kinds of tests to carry out to claim our hypothesis testing. So few of the things are parametric and few are non-parametric. Parametric tests based on assumptions that follow normal distribution or normal family of distribution. Estimator parameter of underlying normal distribution, significance of difference is known. And non-parametric tests are variable under study does not follow normal distribution or any other distribution of normal family. Association can be estimated of this non-parametric tests. So here is a flow chart which I am giving, a complete flow chart under different kinds of hypothesis test, which tests to perform. When you have a single mean, we always go for a variable and we keep on testing one mean. When we have only one mean, it is one sample t-test. In non-parametric, it is sin t-test. When we have two means, we have a paired t-test and an independent test. Paired t-test in the form of parametric and non-parametric in the form of sign test, Wilcoxon sign rank test. And in the independent case, it is t-test and Wilcoxon sign sum rank sum test in the form of non-parametric. And when it comes to more than two means, we go for f-test, that is ANOVA, analysis of variance. Only t-test can be performed if the sample size seems to be 30, and then when we have only two means. When greater than two means, we go for the ANOVA. And in the same case with the categorical data, we go for single group, that is for z-test. And then we have two groups, it is paired t-test, and that is a non-parametric test, McNamara test, and an independent test, that is a famous test called as chi-square test. And then we have more than two groups, we also use a chi-square test. It is a very good test to carry out the analysis. Here we perform one sample t-test. So there is a problem, 10 plants are chosen at random and their heights are found to be in different kinds of centimeters. So here I have framed the null hypothesis that the height of the trees will be 69.6 centimeters. But I have just claimed that's all. Whether it is true or not, we don't know. So alternative hypothesis has to be framed opposite to it, and then we have to test it. Now we will going to test it in SPSS. So this is the first data set which I have already done for your thing. So we will just go analyze, and you should go compare means one sample test, and you transform your data and you claim that your test value, that is to be, what is the test value? It is 69.6 centimeters. So you put that 69.6 centimeters here and click OK. An output will be generated. So it is so we need to see that t-test value here. T-test value is minus 1.823 and the degrees of freedom is 9. The degrees of freedom is we have 10 observations, n minus 1 degrees of freedom, and we always we have to see the significant value. It is not significant here because it is greater than 0.05. So we accept the null hypothesis and we reject the alternative hypothesis. So hence we accept the null hypothesis and we reject the alternative hypothesis. And the next one is independent sample t-test. For the random sample of 10 pigs fed on the diet, the increase in the weights after certain period of this particular thing. So here whether that diet has differ significantly or not. The effect of two diet do not significantly differ significantly. The effect of two diet differ significantly. So in their weights. So we need to see. So we need to perform the independent t-test. Go to the independent t-test. Test variable is this one, BD. That means all these are weights. And then grouping variable is this. And if you click this one, you will generate an output. So it will generate with equal variances and it will generate with not equal variances. So here also we need to see the test statistics value, and here also both the things are not significant. So what will be our hypothesis? It is greater than the 0.05. So it is do not significantly differ. So null hypothesis is accepted, alternative hypothesis is get rejected in this case. So the next one is Parity Test. Parity Test. Here, suppose a sample of n students were given a diagnostic test before studying a particular module, and then again after completing the module do the scores after a module shows an improvement. So here a pre-module score and a post-module score is given, and we need to run in the SPSS how actually these things will work out for us. So PRMS is a pre-module score and post-module score is POMS, and we directly go to the data view, analyze, compare means, paired sample t-test, what are our pairs, transform. Okay, an output is get generated. We always see the significant value and the t-statistic value. So it is 0.004. It seems to be significant. So looking up this in the table gives 0.004. Therefore, there is a strong evidence that that on an average the module does lead to improvements. So the diagnostic test what they have carried out, it will leads to improvement. Next one is one-way analysis of variance. So up to t-test we can test only two means, but when we want to test more than two means, it go for analysis of variance, that is called as F-test. So we will see how actually the analysis of variance can be performed in the SPSS. Here three processes are there. Three processes A, B, C are tested to see whether their outputs are equivalent or not. So the processes are given here, whether we will see their outputs are equivalent or not. Their outputs has to be equal or not, we need to see. Here we have a processes and then their particular treatments. So here go for analyze, go for compare means you have one-way analysis of variance. So you have that is T and a P. You click OK, an output is get generated. This is one-way analysis table. Here also we need to see the F-test, and then it is not significant. So what we need to focus on, this particular element is not significant means in the hypothesis. In the hypothesis, what happens is it remains all the processes are same and all the processes are different. In the null hypothesis case, we have given all the processes are same. In the alternative hypothesis, we have given all the processes are not same. So we generally, what will happen in this case, what conclusion, state your conclusion means all the three processes are same. Whatever the with the testants, whether they are their outputs are equivalent or not, they have asked, and we have accepted our null hypothesis and we have given our conclusion. And in the second case, that is two-way ANOVA, we will see. In this two-way ANOVA, three varieties of coal were analyzed by 4 chemists, and the ash content in the varieties are found to be as under this particular thing. So these are all the ash contents, and carry out two-way analysis of variance and state your conclusions. So here we need to focus on different kinds of varieties of coal and different kinds of chemists who have analyzed and given the ash content to it. So we'll go to the SPSS and we will see how to solve this particular two-way analysis of variance. So here varieties, chemists and ash content I have given. So I will go to the analyze and I will go to general linear model univariate, and I will transform my ash content to it because it seems to be a dependent variable for me. And then here factors and the chemists. And then I will go to the model and I will customize it, and these are my important terms to be discussed. So I will continue. I will click on OK. So here what happens is an ANOVA table is get generated in the form of an F test. These are all the F tests because one F test is conducted under for varieties and one more F test is conducted for chemists. So two of them has to be satisfied. So here also no significant difference exists. So by seeing the significant value, both of them are greater than 0.05. So we can reject our alternative hypothesis and accept the null hypothesis. So in this case too. So this is how we need to carry out the one-way and two-way analysis of variance. It is exactly similar to CRD and RBD. In the next videos, we will understand, give a better picture for these kind of things when we deal with an agriculture examples. And the last one is a Chisquare test. It is a non-parametric test. So here the data is in the SPSS. So test whether the literacy and smoking are independent or not at 5% level of significance. Whether they're independent or not, we don't know actually claim it's as a null hypothesis. So we need to understand whether these two things are same or not. Analyze and then go to the cross tabs. Both are nominal variable. Go to cells, observed, expected, continue, exact, asymptotic only, continue, and statistics. You click on a chi-square and click OK. An output gets generated. Pearson's chi-square value. Here Pearson's chi-square value seems to be 4.443 at 3 degrees of freedom. It is 0.217. So our hypothesis got accepted. That means null hypothesis what we have framed is smoking and literacy are independent. So null hypothesis got accepted. And one more thing, in the chi-square we need to see the count. When we are seeing the count, the numbers within the cell should be more than 5. Then we will going to get an exact chi-square test. And these many, only few observations I have taken. These many numbers should be within 5 of that particular thing. So this is about a non-parametric test. So thank you. There are many tests available for non-parametric. For this class we will end up with this. So if any doubts, please let me know with this mail. Thank you very much.